All right, let's work through question 3. 3.1 asks for the full displayed structural formula of compounds A and B. Let's start with A. Its base is propane, and so let's start with a 3-carbon chain. Then it's got 1,1 dichloro, so 2 chlorine atoms on carbon number 1, and 1 fluorine atom on carbon number 1. Now be careful with the symbol for fluorine. Too many people are writing Fl for fluorine. It's not, it's just F. You can check that on the periodic table. And then the next 2 carbon atoms we just fill up with hydrogens, 2 on carbon 2 and 3 on carbon 3. So that's the full displayed structural formula for compound A. Compound B, propane 1-ol. Again, a prop base, so 3 carbon atoms in the main chain. The 1-ol is an OH group on carbon 1. Remember to put in the bond between the oxygen and the hydrogen, and then we fill up the hydrogens on the other carbons, and that gives us propane 1-ol. Question 3.2, full IUPAC names of C and D. There they are. Let's start with C. We have a 3-carbon chain there, CH3CH2, so I've shown the 3-carbon chain. Let's start from the left. The first carbon has got 3 hydrogens on it, there we have them. The second carbon has just got 1 hydrogen, and the third 2, which means that there must be a double bond between those 2 carbons. And so that then gives us the IUPAC name of propene. You can call it prop-1-ene because the double bonds between 1 and 2, but it couldn't be anything else, so propene will suffice. If we look at D then, again we have a 3-carbon chain. First carbon's got 3 hydrogens on it. Second carbon contains the C double bond O group, and the last carbon 3 hydrogens. And so we've got prop because of the 3 carbons, and we've got a ketone group, and so it's propanone. Alright, 3.3, the homologous series to which E belongs. We identify the functional group, there it is, and hopefully you can recognize that as a carboxylic acid functional group. 3.4, 2 letters of the compounds that are structural isomers. The correct answer to this is B and F. Let me explain why. B is propane 1-ol and F is propane 2-ol, so they're classic structural isomers. Just to check, there's the full displayed structural formula for propane 1-ol, and its empirical formula is C3H8O, and F is propane 2-ol, and its empirical formula is also C3H8O. So if you remember, the definition of an isomer is that 2 compounds that have the same empirical formulas but different structural formulas and hence different names, which is true for B and F. 3.5, the definition of viscosity, that's a liquid's resistance to flow. Then 3.6, which of D or E has the higher viscosity? And explain by referring to the types of intermolecular forces. So the question here is asking you to refer specifically to the names of the intermolecular forces and then indicate which are stronger. Remember, the stronger the forces, the higher the viscosity, because it will resist flowing if the molecules are strongly attracted to each other. So let's have a look at D and E. E is given, it's propanoic acid. D we drew earlier is propanone, and so we need to work out the types of intermolecular forces here. In E we have hydrogen bonds because we have hydrogen bonded to oxygen, which is a highly electronegative element, and in D the carboxyl group, the C double bond O, gives us a dipole-dipole force. So the correct answer here is that compound E has the higher viscosity, and the reason is that E has stronger hydrogen bonds than D, which has weaker dipole-dipole forces.